what if our goal was to take this ketone and end up with this tertiary alcohol where we've added this piece that I'll outline in a green line. And we would initially think that maybe we need a Grignard that looks like this. Where we would add 3 carbons and an OH. This would be the nucleophilic carbon, and it would attack the carbonyl carbon. I hope you're looking at this molecule I drew and saying, well, this is an alcohol, and you told me that Grignards are very, very strong bases. And so most likely this molecule would react with itself to produce one extra carbon here. Most likely this molecule would react with itself to produce this, a magnesium bromide salt of a alkoxide through the proton transfer of this acidic hydrogen onto the carbon. So we can't make this thing. We cannot make this molecule. We need to do something else in order to arrive at our desired product outlined in blue up here. And what we have to do is to protect the alcohol, which essentially means take the OH, transform it to something else, so that the H is no longer an acidic type of hydrogen. It won't react with strong bases. And then later on, we can unmask or deprotect the alcohol, removing whatever we put on it, and producing the OH group again. So how do we do that? Let's look at the same 3 carbon species that we want to use. And if I mixed this, I meant to put a bromine there, if I mixed this with a magnesium, I would have the Grignard. And of course that Grignard would react with itself, and we wouldn't have a viable reagent then. So what we're going to do is react this alcohol in an SN2-like reaction with trimethyl silyl chloride. So I'm going to put 3 methyls around this silicon. Silicon is in the same group as carbon. It does form 4 bonds typically. It is larger though, so it's actually easier to do an SN2 reaction on silicon even if it has 3 groups around it, because you might classify this chloride as a tertiary chloride, and indeed I would agree with that. However, we can still draw a SN2 type mechanism here, and we would end up with this species after we do the proton transfer step, as we learned about in Organic 1. We're also going to use some base here. Triethylamine can be used to remove extra hydrogens. It's a good base, it's not a very good nucleophile, and so basically we put it in there to soak up any base, because we're going to make HCl in this case, and we need the triethylamine to soak that up. So we do the reaction, we now have the O-silicon bond here. We can abbreviate this as bromine OTMS trimethylsilane. And so this molecule has no acidic hydrogen. The OH is not there, it's protected, it's masked. It's not going to react if we turn this into a Grignard. So now we can take our TMS group and react it with magnesium. We would then produce the magnesium bromide version. So now the Grignard. And we have OTMS on the other side. And now I can take this Grignard reagent and I can react it with the ketone that I wanted to react it with, and after the reaction I have this. How do we deprotect the TMS group? How do we remove the TMS group and expose the OH group again? Well, we use a source of fluoride ion, and so it's in one step. I would use tetrabutyl ammonium fluoride, TBAF, and that molecule looks like this. It's actually not a molecule, it's a ion. 4 butyl chains off of a nitrogen give us nitrogen with a plus charge, and the counter ion is fluoride. And if I look back at my OTMS, the fluoride acts as a good nucleophile, basically kicks off this group. And so let's call that the first step. The second step is probably a mild acid workup to provide the hydrogen again. And so we can deprotect with TBAF, tetrabutyl ammonium fluoride. It's a white powder, it's a salt that you can buy and store in a jar. And this is how we could protect alcohols so that they don't act as strong acids. So if we want to perform a Grignard reaction, maybe on an aldehyde or ketone, in the presence of an alcohol, we need to protect it first using this technique with TMS chloride and then deprotection with TBAF at the end of the reaction to basically regenerate the OH group. So we might ask ourselves, how do I make this product from this starting material? And if we examine the product, we can observe that it's probably this bond here that we are creating. We'll notice that we created a secondary alcohol during the reaction. So if we deconstruct that product and look at what the final step should be, somehow, I'm going to use green here, if I have a Grignard reagent or some form of a nucleophile right here, and I react that with the appropriately shaped aldehyde, and of course right here we can observe there's only 2 carbons in that compound, and so we know that if we react Grignards with aldehydes we get secondary alcohols, and so I think these are the 2 pieces that we want to work with to make this transformation happen. And of course we just got done talking about protecting alcohols in order to make the Grignard work, and if I had this compound by itself, the alcohol would just protonate the Grignard and I would be stuck. I would have an alkoxide, I would not have the carbon anion. So really what I should have here is probably the OTS, which we just learned how to make. I'm sorry, OTMS, and the Grignard, and I react these 2 together. The first step would be to mix them together. The second step would be to work up the normal Grignard reaction with water. And the third step would be to add tetrabutyl ammonium fluoride to regenerate the alcohol right here. And so that's going to be my final steps in this sequence. And then I just have to protect my alcohol and then create the Grignard. So if we go here, TMS Cl and triethylamine, or you can draw it out, that's fine. Organic chemists do love their acronyms, but if you prefer to draw the structure, I don't have a problem with that. What this is doing is, of course, protecting the alcohol. And then I have my primary bromide that I'm going to convert to a Grignard. Now I can make the Grignard, and actually it takes it right up to here. Now I've created the Grignard. I can introduce the aldehyde to the Grignard, and then at the end of that reaction I can quench the alkoxide that's formed with water, and then I can regenerate the original alcohol using TBAF, and then I have my diol product that I created up here. So here's a way that we could use the concept of protection, deprotection in a short synthetic pathway.